power integrity constraint sets that you create in the Allegro Sigrity PI application can be reused across designs. In this video, we'll export our power integrity constraint sets from one design and import them into a different design so that we can reuse the information that was captured in the power integrity constraint sets. In the current designs shown, we use the Power Feasibility Editor to create two power integrity constraint sets, one for our DDR memory controller and one for our DDR memory DIMM. We'd like to export those power integrity constraint sets so that we can use them on our other designs that have DDR memory controllers and DIMMs as well. We export our power integrity constraint sets from the Constraint Manager, so we'll invoke the Constraint Manager and go to the electrical domain in the Constraint Manager and open the DCAP template worksheet in the Power Integrity Workbook. And we can see our two power integrity constraint sets, one named DDR_controller and one named DDR_DIMM. Each power integrity constraint set has a 1.8 volt rail and a set of capacitors that need to exist for any of the components assigned to these power integrity constraint sets. We export our power integrity constraint sets by selecting File, Export, Technology File from the Constraint Manager text menu. This will export a technology file with a .tcfx extension and by default put it in our current working directory. For the contents of our technology file, we'll turn off all of the options in the contents section of the export form and make sure we just turn on the power integrity constraints checkbox. And then we'll supply a name for our technology file and select the Save button. A technology file with the information about our two power integrity constraint sets is now saved in our current working directory. Here in our second design, we have a similar memory controller and memory DIMM, and we'd like to apply our power integrity constraint set to these components. We can import the power integrity constraint sets from the Constraint Manager. So we'll invoke the Constraint Manager, and in the electrical domain, we'll go to the Power Integrity Workbook, and we'll open our DCAP template worksheet. And as we can see, we currently have no power integrity constraint sets in our design. Next, we'll select File, Import, Tech File from the Constraint Manager text menu. And we can navigate to and find the technology file that has our power integrity constraint sets, ddr_caps.tcfx. Our tech file only has power constraint sets in it, so we'll merge the constraints in the ddr_caps technology file with the current constraints in our design. And we'll pick the Open button in the import form. After the import is complete, the technology difference report is displayed. The summary indicates that two new power integrity constraint sets have been created in our design, and three new part definitions have been created. Any part definitions required based on the power integrity constraint sets for parts that are not already in our design are dynamically created for us. In the left panel, we can expand the constraint sets item and see the two power integrity constraint sets that were created, one called DDR_controller and one called DDR_DIMM. And for each of the power integrity constraint sets that were created, there's a 1.8 volt rail for the decoupling capacitors of those constraint sets. If we expand the part definition branch, we can see the three capacitor definitions that were created to accommodate our new power integrity constraint sets. We'll close our technology difference report, and in the Constraint Manager, we can now see that we have two power integrity constraint sets defined. We now need to assign our memory controller to the DDR_controller power integrity constraint set and our DDR-DIMM to the DDR-DIMM_constraint set. We do that down in the Components folder using the Power Integrity Workbook and the DCAP template worksheet. The DCAP template worksheet in the component folder lists all the different component types in our design. If we expand the DDR DIM component, we see its reference designator DIM1, and we can select the reference power integrity constraint set cell and assign the DIM1 memory DIM to the DDR_DIM power integrity constraint set. As we assign the DDR DIM to the DDR_DIM power integrity constraint set, the CSET information window opens and shows us that new decoupling capacitors have been created in our design, and it shows us the reference designators and indicates that they've been assigned to the 1.8 volt power rail. Similarly, we'll find our memory controller, reference designator U32, and assign that to the DDR_controller power integrity constraint set. And once again, based on the power integrity constraint sets that we imported, new capacitors are added to our design that need to be placed near our DDR controller to satisfy the requirements of the power integrity constraint set. Now that we've imported our power integrity constraint sets and assigned our memory controller and our memory DIM to the appropriate power integrity constraint sets, when we go to the decap place command, the options form allows us to place our decoupling capacitors based on the information from our power integrity constraint sets. In summary, we created power integrity constraint sets using the Power Feasibility Editor in one design, exported it into a technology file, and made it reusable across other designs with similar memory controller and memory DIM by importing our power integrity constraint sets.